So it says that a certain rocket maintains a horizontal uh, altitude of its axis during the powered phase of its flight at high altitude. The thrust imparts a horizontal component of acceleration, which is 20 feet per second square. So first acceleration which is being applied to your particle, which is rocket in this case, is a horizontal acceleration of 20 feet per second square, right? This one. And a downward acceleration in the acceleration due to gravity at the altitude, which is the 30 feet per second square. So there are two accelerations being applied to your particle. So the second acceleration which it is experiencing is a downward acceleration of 30 feet per second square, right? At the instant represented, the velocity of the mass center g of the rocket along the 15-degree direction of its trajectory is this much, right? So at this particular point, you have a velocity of 12,000 miles per hour, which is making an angle 15 degree with horizontal, right? And for this position, you have to determine the first thing, the radius of curvature of the flight trajectory, rho. Then second thing, the rate at which the v is increasing, so v dot. The angular rate beta dot of the radial line, so beta dot need to be determined. And then finally the vector expression for the total acceleration, so a vector, right? So now it's the case of curvilinear motion, but from the radius of curvature thing, you should realize that you should resolve the acceleration into n and t coordinates, right? So it's a problem of n t coordinate system, because you need to determine radius of curvature, and you should know that it is appearing in the expression a sub n is equal to v square over rho, right? So if you know the n component of acceleration experienced by a particle and velocity of that particle at the same point, then you can use this expression to determine rho, right? So this information should quickly tell you that this is a case of n-t coordinates. So which means that whatever acceleration is given in this problem, we need to write it in n-t coordinate system, right? So this particle is experiencing two accelerations. For example, this is your point G here. It is experiencing an acceleration of 20 feet per second square and a vertically downward acceleration of 30 feet per second square. Obviously, there will be some resultant of these two vectors, but we need to decompose that resultant or resolve that resultant into its corresponding n component and t component, so that we can equate the n component as v square over rho and can determine rho, right? Which is the first thing to be determined. So this is our case A, this is B, then C, and then finally D, right? So for A, the solution strategy should be to resolve the total acceleration into two parts, two components, A sub n and A sub t, right? Anyways, in order to write the total acceleration vector, you need to have those two components, right? So in order to solve for the D part, you again need A sub n and A sub t. Similarly, this V dot is equal to what? It is A sub t. You have seen that already, right? So you need to have A sub t also for part B. And similarly, beta dot is appearing where? In A sub n again, right? A sub n have a different expression which has beta dot in it. So means the whole point is about resolving the total acceleration into its n component and t component. So let's draw on the same figure what is the direction of t and what is the direction of n. Actually, it is already given to you. So t is making an angle 15 degree with horizontal. So this is your t axis. Your velocity is in the same direction. So this is your t axis, and the angle between horizontal direction and t axis is 15 degrees, right? Similarly, the 90° to that t will be your n axis, and that will be making a 15° angle with the vertical axis also, right? So if that angle is 15°, then this angle should also be 15°, right? All clear, right? So now we can resolve this 20 feet into its t component and n component, and similarly this 30 feet per second square also we can resolve it into its corresponding t component and n component, and then see what is the total acceleration in t direction, what is the total acceleration in n direction, right? So let's start by decomposing this 30 feet per second square along t and along n. So the t component will be something like this, right, towards the positive t axis, right, and the n component will be like this, right. So this will be the n component because this is n direction. So this will be the n component of this 30 feet per second square, and since the angle between them is given, I can write it as 30 times 30 cos 15, the component of 30 feet per second square along the n axis. Similarly, this vector, which is the component of 30 feet per second square along t axis, this will simply become 30 sine 15, right? And both will be positive because the t component is in the positive t direction and the n component is towards positive n, which is towards the radius of curvature, right? Center of curvature, sorry. Similarly, let's resolve this 20 feet per second square into a t component and its n component. So t component will be along t axis, so it will be like this up till here maybe, and that will be actually positive, and it will be 20 cos 15 towards positive t axis, but the n component of this 20 will be upwards like this, right? It will be in the negative n direction, and that will be equal to 20 sine 15, right? 20 sine 15. So the total acceleration in the n axis will be like 30 cos minus 20 sine, right? And the total acceleration in the t axis or t direction will be 20 cos plus 30 sine. So both of the components, t components, will be towards positive t, right? So the final thing is that the a sub n should be the component of horizontal acceleration along n axis plus component of vertical acceleration along n axis. When I did that, I actually get these two equations. Total a sub n is equal to 30 cos minus 20 sine, and a sub t will be 30 sine 15 plus 20 cos 15, right? So both of the t components are positive, but one of the n components was negative because it is in the direction of opposite toward of the center of curvature. If you put the numbers in, you get a sub n as 23.8 and a sub t as 27.1, right? Both came out to be positive, which means that the total acceleration would be something like this. If you follow the same figure, the total acceleration would be something like this, right? A sub a vector, the total a vector, because the final t and n both are positive, right? So for example, rho needed to be determined. Rho actually is appearing in this expression. We know that v is given to us, and a sub n, if we determine, we can determine rho, right? So therefore we started our solution by calculating a sub n, or in other words, resolving whatever acceleration is given to us in terms of its t and n components, and then summing the accelerations in both t and n components. So you may have more than two accelerations, but all need to be resolved along n and t axis. So once the a sub n is determined, we can calculate rho using this expression, right? But obviously velocity was given in miles per hour, and the problem is in feet and second units. So we need to convert miles per hour to feet per second. So I actually did that conversion here. So finally I arrived at this conclusion that 1 mile per hour is equal to this much feet per second. So now I just put the numbers in. Rho is equal to V square over A sub n, right? So it's V square over A sub n. Apply the formula, A sub n is equal to V square over rho, right? So V need to be converted from miles per hour to feet per second square divided by A sub n. Now the units are consistent. We can determine rho in feet directly, and it came out to be this number, right? So this was your part A, and again I would repeat that please don't only focus on this particular problem, think of it as one problem type, right, in which you need to be calculating the radius of curvature using some given information. So up till now we learned that whenever you need to determine radius of curvature, it has something to do with A sub n, which means you need to use nt coordinate system and try to calculate the n component of acceleration first. The second part was determine v dot, and v dot we know is equal to a sub t, right? And a sub t we have already determined as part of the first case. We have determined a sub t already, although it was not used here, but it is equal to 27.1 feet per second square. So this will be simply the value of v dot, right? So no calculation required for this part B. Part C was saying determine the rate of change of the angle beta, which means beta dot, and we know that v is equal to rho beta dot, and velocity was again given 120 miles per hour. Rho has been determined already in part A, so we can calculate beta dot as v over rho, right? Alternatively, you can also use again the another expression for a sub n, which involves beta dot, right? It's same thing. So you will be getting beta dot in radians per second, right? If your units are already feet per second and rho is in feet. Finally, they ask you to write the total acceleration vector in vector format. So it will be simply a sub n times e sub n unit vector plus a sub t times e sub t unit vector. We have already determined both a sub n and a sub t, and the final acceleration vector will be this number, right? It will be in feet per second square. If you want to see its direction, it will be somewhere towards the diagonal, because we know that a sub t was a positive number 27.1, a sub n was also a positive number 23.8, so somewhere between them will be your a. Actually, you can also determine the exact angle which it is making with a particular t axis or n axis, right, by taking tan inverse the ratio of their components, right? So this is your final acceleration vector when described in nt coordinate system, right? So the summary is that I actually learned how to write acceleration in n and t coordinate system, right? Just like we were doing it for x and y coordinates, now we are using a different, like a rotated axis, one of which is towards tangent direction to the path and the other is perpendicular to that.